The universe begins in silence, not the silence of emptiness, but the quiet hum of everything yet to exist, the stillness before the first light. Nearly 14 billion years ago, space itself began to stretch, carrying within it the seeds of stars, galaxies, and time. That first expansion was gentle at first, almost imperceptible. And yet from that subtle swelling, every atom that would one day form you was set into motion. Even now, the universe continues to expand, slowly, endlessly, like a calm breath drawn by creation itself. Out there, beyond the thin veil of our atmosphere, lies a world so vast it defies imagination. Each point of light you see in the night sky is a sun, some small, some enormous, each surrounded by its own system of planets, moons, and dust. Astronomers believe there are more stars in the universe than grains of sand on all the beaches of Earth. Each one burns with quiet determination, converting hydrogen into light, feeding the darkness with gentle fire. Our own sun is among the quieter ones. Not too big, not too small, a steady heart at the center of our tiny cosmic neighborhood. Every second, it releases more energy than humanity has ever produced. Yet from 93 million miles away, that power feels soft, life-giving, and constant. Its light takes a little over 8 minutes to reach us, crossing the cold of space just to rest upon our planet. When that light touches your skin, you are feeling something that began its journey before you finished your last breath. Around this calm star, 8 planets drift in a slow, endless dance. The inner ones are small and rocky. The outer ones are giants, made mostly of gas and dreams. Jupiter spins the fastest, completing a day in just 10 hours, while Saturn turns more slowly, wrapped in rings made of ice and dust. Those rings are not solid. They are countless frozen particles, each orbiting at its own pace, glittering like shards of glass in sunlight. Beyond them, Uranus tilts on its side, as if resting against the fabric of space. Its seasons last more than 20 years each, as sunlight drifts gently across its pale blue clouds. And farther still, Neptune roars with winds faster than sound, turning endlessly under the distant glow of the sun. Beyond Neptune lies a frontier of darkness, the Kuiper Belt, where tiny frozen worlds like Pluto wander in slow orbits that last centuries. Each of these worlds, from Mercury's scorched face to Neptune's icy storms, tells a quiet story about the birth of our solar system. Billions of years ago, clouds of dust and gas began to swirl, drawn together by gravity. Tiny grains collided, stuck, and grew. Pebbles became mountains, mountains became worlds. And from that chaos, harmony emerged. 8 planets, moving together in balance, each obeying the same invisible rules. Between the planets drifts the occasional visitor, a comet, bright and fleeting. When one falls toward the sun, the warmth awakens its frozen core, releasing streams of gas and dust that stretch across millions of kilometers. From Earth, those tales appear soft, ghost-like, ancient messengers from the dawn of the solar system. And yet, even our solar system is small, a speck within a galaxy of 100 billion suns. The Milky Way stretches across the sky like a faint river of light, its spiral arms rotating slowly around a dark, invisible center. At that center lies a supermassive black hole, 4 million times the mass of our sun. It does not devour the galaxy. Instead, it anchors it, holding the stars in their vast, graceful orbits. Black holes are strange and quiet things. When a massive star dies, its core collapses under its own weight, squeezing matter into a point so dense that space itself folds inward. Not even light can escape, but far from being destroyers, black holes are also creators, sculpting galaxies, bending time, stirring the fabric of the universe itself. If you could drift close enough, time would begin to slow. 1 minute near a black hole could feel like years to someone far away. It's not magic, it's gravity reshaping time, showing us that even the laws of the cosmos have softness and stretch. Between those gravitational giants, the galaxy glows with clouds of gas and dust called nebulae. Some are nurseries where new stars are born. Others are the remains of those that have died. The Orion Nebula, visible through a simple telescope, is one of the brightest, a cradle of young stars wrapped in shimmering pink light. Within it, matter gathers and ignites, just as it once did to form our sun. If you could stand there, surrounded by that glowing mist, you would see light being born, calm, steady, ancient. And beyond our galaxy lie others, countless and varied. Some spiral elegantly like ours. Others are shaped like ovals, or stretched thin by collisions over cosmic ages. The nearest Andromeda is on a slow journey toward us, a collision so vast it will take 4 billion years to occur. When it finally happens, stars will drift past each other without touching, like fireflies passing in the dark. The galaxies will merge, forming a new one, quieter, brighter, and endlessly patient. Everywhere we look, the universe moves, but not with haste. Even light, so fast that it circles Earth 7 times in a second, takes years, centuries, even millennia to reach us from distant stars. When you look at the night sky, you are not seeing the present. You are gazing into memory. Every shimmer is a story from the past, traveling across the dark to tell you it once existed. And in that gentle light, the universe feels almost human, full of age, patience, and quiet endurance. It holds within it everything that has ever been, the ashes of ancient stars, the elements of life, the silence of eternity. And as you listen, as your breath slows and your eyes grow heavy, you are floating within that same cosmic calm. Because the universe is not only around you, it is within you, the same atoms, the same light, the same timeless rhythm. Space is not still. It stretches, slowly, invisibly, like a calm breath drawn across eternity. When the universe began, it was smaller than an atom, a dense and brilliant spark containing everything that would ever exist. In that first moment, there was no outside, no space around it, no silence to break. There was only expansion, the quiet blooming of existence itself. Scientists call that first moment the Big Bang, though it was not a bang at all. There was no sound, no explosion. It was more like a dawn, a sudden release of light, energy, and time. In less than a heartbeat, the universe grew from microscopic to enormous, faster than light itself could travel. And then, slowly, the expansion began to calm. From that point onward, the cosmos has been breathing outward, growing larger every second, even now. If you could watch galaxies from far away, you'd see them drifting apart like lanterns on a dark ocean. Every moment, the space between them stretches a little more. This is not because the galaxies are moving through space, but because space itself is expanding, carrying them gently with it. For billions of years, this movement went unnoticed. Only in the 20th century did astronomers like Edwin Hubble discover that the light from distant galaxies appeared redder than it should be. That red tint, the redshift, is the signature of motion. It means that those galaxies are moving away, and the farther they are, the faster they go. This expansion continues today, quietly and endlessly. No edge, no center, just more and more space unfolding everywhere at once. The universe isn't expanding into anything, it's creating the fabric of somewhere as it grows. It's as if every corner of existence is a drop of ink spreading gently through still water. Yet the story is stranger still. In the 1990s, scientists discovered that this expansion isn't slowing down, it's speeding up. Something unseen is pushing galaxies apart faster and faster. They call it dark energy, though the name is only a placeholder for mystery. It makes up about 70% of everything, yet we don't know what it is. It doesn't shine, it doesn't interact. but it shapes the destiny of the cosmos. Imagine that. Most of the universe is invisible. In fact, the matter that forms stars, planets, and everything we can see, you, me, oceans, clouds, the glow of the Milky Way, makes up less than 5% of all existence. The rest is dark energy and dark matter, two unseen presences that together hold and stretch the universe like a silent rhythm. Dark matter does not emit light, but it reveals itself through gravity. Galaxies spin so fast that without it, their stars would fly apart. Something invisible holds them together, a hidden web of matter threading through the cosmos. Astronomers map it not by sight, but by the way galaxies bend light as it passes through, like glass bending water. It is believed that this cosmic web, a vast network of filaments made of dark matter, connects every galaxy, forming the large-scale structure of the universe. If you could see it, it would look like a glowing lace of light, clusters of galaxies joined by thin bridges surrounding immense, silent voids. Each glowing knot in this web is a galaxy cluster, a city of trillions of stars. And in between those cities stretches a darkness so deep that it almost feels like sleep. Our galaxy, the Milky Way, is one of these bright knots. It drifts along the web, pulled by gravity, pushed by expansion, part of a cluster known as the Laniakea supercluster, a vast region spanning more than 500 million light-years. Within that expanse lie thousands of galaxies, each spinning, shining, and fading in their own quiet time. As the universe expands, light itself stretches. Photons traveling through growing space lose energy, their waves lengthening into red, then infrared, then microwave. The oldest light we can see, the cosmic microwave background, is the faint afterglow of the Big Bang. It still fills the sky everywhere, like a soft, invisible mist of ancient warmth. It's only a few degrees above absolute zero, cold beyond imagination, yet it carries the memory of everything that came before stars, before galaxies, before form itself. If you could listen to that light, it would hum softly, like a whisper from the beginning of time. This radiation, discovered by accident in 1965, is proof that the universe once burned bright and hot. Now, billions of years later, it has cooled and calmed, drifting toward quiet. Everywhere we look, we see the past. Light takes time to travel, so a galaxy a million light years away shows us what it looked like a million years ago. The farther we look, the younger the universe appears. Through telescopes, we can peer back almost to the dawn, to the first galaxies, faint and small, forming from clouds of hydrogen and helium. Each image is not just a picture of space, but of time itself unfolding. And still, the expansion continues. There will come a far future, trillions of years from now, when distant galaxies will slip beyond visibility. Their light will stretch until it fades entirely, leaving only the faint glow of our own stars. Future observers, if any remain, will look to the sky and see only darkness, unaware that beyond their horizon lies a vast, unreachable cosmos. But that is not our time. Tonight, the universe is still full of light. Billions of galaxies, each with billions of stars, still glow and spin and drift through expanding space. And you, on this small blue planet, are part of it all, an observer of motion that began long before life existed and will continue long after. So as you breathe and listen, remember, the universe does not move through space. It is space, unfolding softly around every atom, every star, every dream. And within that endless motion, there is calm, the slow rhythm of creation continuing forever. In the beginning, there was only darkness, not empty, but full of quiet potential. For millions of years after the universe began, there were no stars, no galaxies, no light at all. The cosmos was a vast sea of invisible hydrogen, spread thin and cold, waiting for gravity to begin its slow and patient work. Over time, tiny ripples formed within that darkness, gentle unevenness in the sea of gas. Where the gas was slightly denser, gravity began to pull more of it in, forming small clouds that slowly grew heavier. It was a quiet process, unfolding over millions of years, as invisible matter gathered into glowing knots of creation. Inside those clouds, pressure built. As more atoms fell inward, the gas at the center began to heat. When the temperature climbed high enough, about 10 million degrees, something remarkable happened. The first stars were born. Hydrogen, the simplest element in the universe, began to fuse into helium. That reaction released light, pure, radiant, unstoppable. And for the first time, the universe glowed. These first stars were enormous, hundreds of times the size of our sun. They burned fiercely and lived briefly, flooding space with ultraviolet light. Their energy cleared away the surrounding fog of hydrogen, revealing the structure of the universe for the first time. And when they died, they did so in great explosions, supernovae that scattered heavy elements into the void. Those scattered elements, carbon, oxygen, iron, became the building blocks of future stars, planets, and eventually, life. You are made of those ashes. Every atom in your body, heavier than hydrogen, was forged in the heart of a star that lived and died long before our sun was born. The birth of a star is both violent and delicate. It begins within vast cold clouds called nebulae, where gravity slowly gathers dust and gas into tighter clumps. From the outside, these clouds appear soft and luminous, pink and violet curtains of light suspended in the dark. But within them, chaos reigns. Jets of gas burst outward from forming stars, while magnetic fields twist and shape the flow of matter. One of the most beautiful nurseries is the Orion Nebula, hanging below Orion's belt in the night sky. It is about 1 to 300 light-years away, a swirl of glowing gas where hundreds of newborn stars sparkle like embers. Each of them is surrounded by a disk of dust, the early outline of future solar systems. Within those disks, grains of material collide gently, stick together, and begin to grow. Over millions of years, they form small worlds, the first planets. So, every star that forms in the universe has the potential to bring with it a family of worlds, each orbiting like quiet companions in the cosmic dark. Our own sun was born in such a cloud, roughly 4.6 billion years ago. It likely formed alongside hundreds of sibling stars, though they have long since drifted away. What remains is our solar system, a quiet reminder of that ancient nursery. Not all stars are the same. Some are tiny and cool, called red dwarfs. They burn their fuel so slowly that they can live for trillions of years, far longer than the universe has yet existed. Others are massive and bright, shining blue-white, and living only a few million years before collapsing in spectacular deaths. The more massive the star, the shorter its life, and the more dramatic its end. Inside every star, gravity and pressure perform a delicate dance. Gravity pulls matter inward, trying to crush the star. But the heat from fusion pushes outward, holding it in balance. This equilibrium can last billions of years as the star quietly transforms hydrogen into helium, releasing light that travels through space to warm, distant worlds. When we look at the night sky, the light we see began its journey long ago. The glow from Sirius left its home 8 years ago. The light from Deneb began when humans were still learning to write. Every star is a time traveler, sending messages across the ages. And when their light reaches your eyes, you are witnessing both the present and the ancient past at once. Some stars form pairs or even triplets, orbiting each other in graceful harmony. Others are part of clusters, hundreds or thousands of stars born from the same cloud, bound by gravity like siblings. Over time, these clusters drift apart, scattering their stars throughout the galaxy. Eventually, every star must change. When the hydrogen in its core runs low, gravity begins to win the battle. The core contracts, the outer layers expand, and the star swells into a red giant. Our own sun will one day grow large enough to engulf Mercury and Venus, and perhaps even Earth. But that won't happen for another 5 billion years. When its outer layers drift away, what remains will shrink into a white dwarf, a small, dense ember glowing faintly in the dark. It will no longer burn, only cool slowly over eons, until it fades completely. Even in death, it will hold the memory of light. Some stars die with more drama. The most massive collapse violently, triggering supernovae that can outshine entire galaxies for a moment. What's left behind may become a neutron star, packed so tightly that a spoonful of its matter would weigh billions of tons. And if the star is heavy enough, it collapses completely, becoming a black hole, an invisible well of gravity where time itself slows. From darkness to light, and back to darkness again. That is the rhythm of the universe. Every bright star you see was once dust and will become dust again. And from that dust, new stars will rise, continuing the cycle forever. So when you look up at the night sky, remember, every twinkle is a story of birth, of fire, and of time. You are not just watching stars. You are watching creation in motion, quiet, endless, and beautifully alive. If the stars are single sparks, then galaxies are their cities, vast communities of light, drifting through the silent sea of space. Each galaxy is a collection of billions, sometimes trillions of stars. They move together, bound by the invisible hand of gravity, turning slowly in cosmic time, their arms curling like petals of light. Our own home, the Milky Way, is one of them, a spiral galaxy about 100,000 light-years across. From within, we cannot see its full shape. We live among its stars, deep inside one of its arms, like a single grain of sand lost on a beach that stretches forever. When you look up on a clear, dark night and see the pale band of the Milky Way crossing the sky, you are gazing along that spiral arm through countless suns and worlds. The Milky Way spins gently, one full rotation every 230 million years. In that time, entire species rise and fall, continents drift, oceans shift. The galaxy moves slowly, patiently, like a great clock made of light. Beyond our home, there are uncountable others. The Andromeda Galaxy, our nearest large neighbor, glows faintly in the constellation of the same name, 2.5 million light-years away. Its light began its journey toward us long before humans existed. When it finally reaches your eyes, you are seeing a memory from a time before history. Andromeda is on a slow, inevitable path toward us. In about 4 billion years, it will collide with the Milky Way. But it will not be a violent crash. Space between stars is vast and mostly empty. The two galaxies will pass through each other, their stars weaving intricate paths, gravity reshaping them into a single larger galaxy, perhaps to be called Milkomeda. For a brief moment, the night sky will blaze with streams of stars as the two cosmic spirals merge into one. Galaxies come in many forms. Some are graceful spirals, their arms sweeping outward in perfect symmetry. Others are elliptical, smooth and rounded, filled with older stars that shine with a dim golden light. Some are irregular, torn and twisted by cosmic encounters, looking like clouds of scattered jewels. Each type tells a story of how it came to be, whether born calm or shaped by collisions over eons. The centers of galaxies often hold mysteries. At the heart of the Milky Way lies a supermassive black hole, about 4 million times the mass of the Sun. It is called Sagittarius A. We cannot see it directly, but we can observe the way nearby stars whirl around it at incredible speeds. It is a reminder that gravity, the same gentle force that holds your feet to the ground, can also shape the largest structures in existence. Around the black hole, Gas and dust spiral inward, heating up and glowing before disappearing beyond the event horizon, a point from which not even light can escape. This process can release enormous energy, sometimes brighter than all the stars in the galaxy combined. In distant galaxies, these active centers blaze as quasars, beacons visible from billions of light-years away. Each quasar is like a cosmic lighthouse, powered by a feeding black hole, sending out waves of energy across the universe. They are the ancient voices of the cosmos, whispering from a time when galaxies were young and wild. Between galaxies stretches the intergalactic medium, a nearly empty expanse, thinner than any vacuum we can create on Earth. Yet even here, faint threads of gas and dark matter connect galaxies like a hidden web. Astronomers call this the cosmic web, a vast structure spanning the entire universe. Galaxies gather along its filaments like dewdrops on a spider's thread. In this grand tapestry, no galaxy is truly alone. They move in clusters, drawn together by gravity. Some clusters hold thousands of galaxies, swirling around a shared center. The Virgo cluster, for example, lies about 50 million light-years away and contains more than 1,000 galaxies. Our own Milky Way belongs to a smaller family called the Local Group, which includes Andromeda and a few dozen smaller companions. If you could step outside the universe and look down upon it from afar, an impossible dream, you would see a pattern that resembles lace or foam or coral. Bright clusters of galaxies linked by glowing filaments, separated by dark voids, where few stars ever formed. It is beautiful and serene, a silent geometry of light. Galaxies themselves evolve. They grow by consuming smaller ones, a slow cosmic dance of merging and absorption. Over billions of years, spirals can become elliptical, their delicate arms disrupted by gravitational tides. But even in these transformations, beauty remains. Stars continue to form, and life may still arise on worlds orbiting quiet suns, unaware of the grand motions above. When you look at a distant galaxy through a telescope, you are looking back in time. The light from the farthest galaxies we can see began its journey more than 13 billion years ago, not long after the universe itself began. To gaze at them is to see the universe as it once was, young, turbulent, glowing with new creation. The Hubble Space Telescope once stared at a tiny, dark patch of sky for days, collecting faint light from galaxies too dim to see otherwise. When the image was revealed, it showed thousands of them, each one a complete universe of its own. The lesson was humbling. Wherever we look, there is something. The darkness between stars is not emptiness, but distance. Within every galaxy, the story repeats. Gas becomes stars. Stars create heavier elements. Those elements form planets, and from planets may come life. Each galaxy may host billions of worlds where the night sky looks different, yet the same laws of nature apply. Somewhere, perhaps, another being might look up at its own stars and wonder, as we do, what lies beyond. In this vast cosmic garden, galaxies are the flowers, blooming and fading across time. Their light crosses unimaginable distances to reach us, soft and ancient, carrying the memory of creation. To know them is to remember how small we are, yet how deeply we belong to something infinite. When you close your eyes tonight and imagine the stars, think not just of single points of light, but of entire galaxies, vast cities in the night, each filled with stories, each alive with motion and wonder. They drift together in the endless quiet, whispering to one another across eternity. There is a strange truth about the universe. It is not still, it is expanding. Every galaxy, every cluster of stars, every thread of cosmic dust is carried outward, as if space itself were gently stretching in all directions. And this expansion is not like objects moving through space. It is space itself growing. Quietly, invisibly, without sound or wind, only the soft rhythm of creation continuing. More than a century ago, astronomers noticed something unexpected. When they observed distant galaxies, they found their light was stretched toward the red end of the spectrum, a phenomenon called redshift. It meant those galaxies were moving away from us, and not just a few, almost all of them. The farther away they were, the faster they seemed to recede. From this quiet pattern, one profound idea emerged. The universe itself was expanding, not into something, but from itself, like the surface of a balloon growing larger as air fills it. If you imagine galaxies painted on that balloon, each one moves away from all the others, even though none are at the center. That is how our cosmos behaves. Every point drifting from every other, carried by the invisible growth of space. This discovery reshaped our understanding of everything. It meant that long ago, all matter, all energy, and all space itself were once concentrated together in a single dense, hot state. From that moment, what we now call the Big Bang, the universe began its long journey of expansion and cooling, a silent unfolding that continues to this day. But Big Bang is a misleading name. It was not an explosion in space. It was the birth of space itself. There was no outside, no before, only the sudden beginning of time and the quiet blooming of everything that would ever be. In those first moments, the universe was unimaginably hot, filled with light and energy. As it expanded, it cooled. Protons and neutrons formed. Then the first atoms, then light began to travel freely for the first time. That ancient light, stretched and softened by billions of years of expansion, still fills the universe today. We call it the cosmic microwave background, a faint afterglow of creation that hums across all of space. If you could listen to the silence of the cosmos, that faint background would be its oldest whisper, the memory of when the universe first became transparent. It is everywhere, passing through you right now as it passes through everything that exists, soft, ancient, and calm. For billions of years, the universe continued to expand, but not evenly. Gravity gathered matter together into filaments and clusters. Galaxies formed, stars ignited, and worlds were born. But through it all, the fabric of space kept stretching, so slowly we could not feel it. Only when we look deep into the past, at the light from ancient galaxies, do we see how far they've drifted. At first, scientists thought this expansion might be slowing down, that gravity would eventually pull everything back together in a grand collapse. But when they measured the most distant galaxies, they found something astonishing. The expansion was not slowing, it was speeding up. Something invisible and mysterious was pushing the universe apart with increasing force. They called it dark energy. We do not yet know what it is. It cannot be seen or touched, but its effect is everywhere, a quiet pressure that stretches the very fabric of reality. Dark energy makes up nearly 70% of the universe. It surrounds us, fills the spaces between galaxies, and shapes the destiny of everything. Because of it, the night sky will grow emptier over time. Galaxies beyond our local group will drift farther and farther away until their light can no longer reach us. The cosmos, from our point of view, will slowly fade into darkness once again. It is a poetic symmetry. The universe began in light, and may one day return to quiet shadow. But that shadow will not be an ending. It will be another form of stillness, another chapter in a story too vast for our lifetimes to read. Even now, the expansion continues silently, faster and faster. You cannot feel it, yet it carries everything. The stars, the planets, even the space between atoms, within its invisible tide. On the grandest scale, everything drifts, yet locally, we remain bound together by gravity, by warmth, by memory. Think of it like this: the universe is breathing. Each galaxy is part of that breath, expanding outward into the infinite. And you, in your quiet room, are made of the same material that fills that cosmic breath. The atoms in your body were once scattered by ancient stars, carried by this very expansion to where you now exist. When you look at the night sky, you are seeing not a static picture, but motion, slow, endless motion. The light from galaxies carries with it the rhythm of the universe's growth. Each photon stretches as it travels, like a note softening as it echoes in a vast hall. By the time it reaches your eyes, it has crossed billions of years, and still it glows. Someday, far in the future, new civilizations may look up and see only their own galaxy surrounded by darkness. The rest of the universe will have faded from view, carried beyond the horizon of light. They may wonder if the cosmos ever held anything more. But hidden within their own stars, in the atoms of their own bodies, will be proof that they are part of something that once stretched forever. So the universe grows, not loudly, but with infinite patience. Every second, every breath, it expands a little more, writing new space between the galaxies. And though it is vast beyond comprehension, you are not separate from it. You are a moment in that expansion, a ripple in its story, made of the same matter, moving in the same quiet rhythm. When you close your eyes, imagine the stars drifting gently away, like lanterns carried by a cosmic tide. No rush, no noise, just the soft unfolding of time and distance. That is the universe growing, silently, eternally, beautifully. As we drift through the universe, one truth becomes clear. When we look at the stars, we look back in time. Light is not instantaneous. It travels across the void at 300,000 kilometers per second, yet the distances in space are so immense that its journey can last thousands, millions, or even billions of years. Every photon that touches your eyes is a messenger from the past. The sun's light takes about 8 minutes to reach Earth. When you feel warmth on your skin, you are sensing energy that left the sun before you completed your last thought. It is a gentle reminder that even the simplest experiences are tied to the vastness of space and time. The stars beyond our solar system take much longer to share their story. Sirius, the brightest star in our night sky, shines from 8 light years away. Its light began traveling when humans were still forming early civilizations. Deneb, a more distant star, is so far that the light we see tonight began its journey before humans even walked upright. Galaxies even farther tell tales older than humanity itself. The Andromeda Galaxy, 2.5 million light-years away, shows us a version of itself from 2.5 million years ago, a time when Earth's earliest ancestors were discovering fire. And when we peer at galaxies at the edge of our observational limits, we see the universe as it appeared less than 1 billion years after the Big Bang, still young, chaotic, and full of light. This is the essence of astronomy, to see not just where things are, but when they were. It is a voyage through both space and memory. Every telescope is a time machine, and every observation is a glimpse into the past. Even the faintest glows tell stories. The cosmic microwave background, the afterglow of the Big Bang, bathes the universe in ancient light. It is almost uniform, but subtle variations in its intensity reveal the seeds of galaxies, the scaffolding upon which cosmic structures grew. In that light, we can read the whispers of creation, billions of years after it began. Time, as we perceive it on Earth, is a gentle flow. Sunrise, sunset, the rhythm of breathing. In the cosmos, time is entwined with space itself. Near massive objects, such as black holes, it bends and stretches. A clock near a black hole ticks more slowly than one far away. Light curves around it, tracing invisible pathways. Gravity and time dance together, shaping the universe silently and perfectly. Consider a star forming in a distant nebula. It may take millions of years to ignite, yet by the time its light reaches us, its story has already unfolded long ago. We see the calm after the chaos, the radiant glow of equilibrium, unaware of the storms and collisions that created it. Even light has limitations. There are places in the universe so distant that their light will never reach us, carried beyond our horizon by the continuous expansion of space. Those regions exist, yet remain forever hidden from our eyes. In that mystery lies a gentle humility. The universe is larger, older, and more wondrous than we can ever fully perceive. Every photon we observe has traveled across vast emptiness, encountering gravity, dust, and other stars, each interaction subtly changing its path. By the time it reaches us, it has carried the accumulated history of its journey, a tapestry of light woven over eons. When you gaze at the night sky, each point of light is a thread in this tapestry, connecting your present to a past that began long before life on Earth. Even the light we see from the moon and planets is a journey through time. Reflected sunlight takes just seconds to reach our eyes, yet it connects us to the immense distances between worlds, reminding us that the cosmos is alive with motion and story. And so, in the quiet of night, as your breathing slows and thoughts begin to fade, consider the calm voyage of light. It flows endlessly across the universe, gentle, unwavering, a cosmic lullaby. Stars and galaxies, near and far, send their history across the void. They whisper of beginnings, of change, of the persistent beauty of existence. In the darkness, time itself stretches. A photon, released from a newborn star, glides through space for billions of years, unhurried, until it reaches an eye willing to receive its message. In that instant, the past and present meet, and the universe becomes intimate, vast yet tender, eternal yet personal. And tonight, as you listen, you too are part of that journey. The atoms of your body, forged in ancient stars, the molecules of air and water, the warmth of your skin, all have been shaped by cosmic time. You are both observer and participant, carrying within yourself the echo of distant light. Let your mind drift along with those photons. Imagine gliding through space, past forming stars, along spiraling galaxies, following beams of light that began their journey when the universe was young. Feel the quiet of infinite distances, the gentle stretch of expanding space, the soft glow of countless suns, and in that vast calm, allow yourself to relax completely. The universe is speaking in light, in rhythm, in silent, endless motion. And you, breathing softly, are listening. The past unfolds in your awareness, and the future continues its gentle growth. Time, light, and the cosmos are entwined, cradling you in a lullaby billions of years in the making. In the quiet darkness of the universe, there are regions of color and light that seem almost alive. Nebulae, the nurseries where stars are born. These vast clouds of gas and dust drift through space, spanning tens to hundreds of light years. From a distance, they appear as gentle smudges of pink, blue, or green, glowing softly against the black canvas of the cosmos. But within them, slow, deliberate forces are at work, shaping the next generation of stars. Nebulae come in many forms. Some called emission nebulae shine because their gas is energized by nearby young stars. Their hydrogen glows red, helium glows blue, and traces of oxygen shimmer in soft greens. Others, reflection nebulae, are calm mirrors, reflecting the light of stars nearby like clouds catching the first light of dawn. And then there are dark nebulae, dense and quiet, obscuring the light of stars behind them, like shadowed corners of the universe holding secrets. One of the most famous examples is the Orion Nebula, about 1,300 light-years from Earth. Through a telescope, it is a swirl of pink and violet, with hundreds of newborn stars sparkling within its mist. Some are just forming, surrounded by disks of dust, the beginnings of solar systems. Each of these young stars may eventually host planets, moons, and perhaps even the conditions for life. Inside a nebula, the process of star formation is delicate. Gravity slowly pulls together clumps of gas, increasing density in some regions more than others. As matter accumulates, pressure rises and the center begins to heat. When it reaches a critical temperature, fusion ignites and a star is born. This can take hundreds of thousands of years, slow, patient, and almost imperceptible in the grand scale of the cosmos. Nebulae are also the remnants of death. Supernova remnants, for instance, are clouds left behind when massive stars explode at the end of their lives. The Crab Nebula, located about 6,500 light-years away, is the glowing remains of a star that died in 1054 Anno Domini. Its light reached Earth in ancient times, observed by civilizations around the world, and today we still study its intricate filaments of gas and magnetic fields. Some nebulae are shaped by stellar winds, streams of particles ejected from massive young stars. These winds carve cavities and sculpt towers of dust, creating shapes that look almost like sculptures frozen in space. The pillars of creation within the Eagle Nebula are one such example. Giant towers of gas standing tall, cradling new stars within. These structures are light years in height, their tips glowing as radiation from nearby stars slowly erodes the clouds. Nebulae are also responsible for distributing elements throughout the galaxy. Stars formed within them forge heavier elements in their cores: carbon, nitrogen, oxygen, iron, and when they die, they release these elements back into space. This cosmic recycling ensures that every planet, every ocean, every living organism is made from material forged in the hearts of ancient stars. Even the atoms in your body, the calcium in your bones, the iron in your blood, may have once floated in a nebula millions of years before Earth existed. Within nebulae, star formation is rarely uniform. Some regions birth clusters of stars, tightly packed and gravitationally bound. Others produce solitary stars, slowly forming in isolation. The variety is astonishing. Some stars are tiny red dwarfs, burning steadily for trillions of years, while others are massive blue giants, living fast and dying in spectacular supernovae. The colors of nebulae are not just for beauty, they are signs of chemical composition. Hydrogen glows red, the most common element in the universe, forming the backbone of star formation. Oxygen produces greenish hues, while sulfur gives off deep red light. Astronomers use these colors to map the distribution of elements, understand stellar evolution, and even measure the speed of expanding gas clouds. Nebulae can be vast and sparse or dense and compact. The Orion Nebula is relatively close and easily visible, while others, like the Carina Nebula, span hundreds of light years and are home to some of the most massive stars known. These giant stars shine millions of times brighter than our sun, their radiation shaping the clouds around them, pushing gas outward and sometimes triggering the birth of new stars. Within the calm of these clouds, planets may begin to form quietly around young stars. Disks of dust coalesce, small grains collide, stick together, and gradually grow into pebbles, rocks, and eventually planetary embryos. Over millions of years, the seeds of worlds emerge, waiting to become complete solar systems. And so, nebulae are not only cradles of stars, but also the first whispers of planets, moons, and possibly life itself. Sometimes, nebulae are transient. Stellar winds and supernova explosions can disperse the gas, ending one cycle of creation. Yet even in dispersal, their material continues its journey, carried by gravity and cosmic currents to form the next generation of stars and planets. Creation and destruction exist side by side, a quiet rhythm that has continued for billions of years. Nebulae are scattered throughout the galaxy, hidden in plain sight or visible as soft glows in the night sky. Even the faintest, distant ones can reveal profound truths about the cosmos, the chemistry of stars, the mechanics of gravity, and the passage of time on scales far beyond human comprehension. When you imagine drifting through a nebula, consider its scale. Light years of gas, dust, and young suns. It is both chaotic and orderly, violent and gentle. It glows with the potential of creation, a reminder that even in darkness, the universe is always building, always giving rise to light. And so, as you breathe and relax, picture yourself floating through these cosmic nurseries. The soft reds and blues of gas swirl around you, stars ignite slowly, their warmth spreading gently across the void. Time stretches, and you feel the patience of the cosmos, the infinite care it takes to sculpt galaxies, stars, and worlds. Nebulae are proof that the universe is never still, that creation is always ongoing. Every twinkle you see in the sky may have been born in a nebula just like these, millions of years ago, quietly igniting in the darkness, and within that process, the universe whispers its eternal lullaby, calm, patient, and endlessly beautiful. In the vast darkness of the universe, there are places where light itself struggles to escape. These are black holes, mysterious regions where gravity reigns supreme. They are silent giants, invisible to the eye, yet their presence shapes the cosmos in profound ways. Black holes form when massive stars reach the end of their life. After millions of years of burning, the fuel in their cores is exhausted. Gravity, once balanced by the pressure of fusion, gains the upper hand. The star collapses inward, its core compressing into an incredibly dense point called a singularity. Around it lies the event horizon, the boundary beyond which nothing can return. Not even light. Though black holes are invisible, their influence can be observed. Stars orbit them, gas spirals inward, and X-rays are emitted as matter accelerates and heats up. Some black holes are quiet, dormant, while others are active, feasting on surrounding matter. When they consume, they can release more energy than an entire galaxy, yet do so without sound, silently reshaping the universe around them. Our galaxy harbors a supermassive black hole at its center. It is called Sagittarius A. It contains about 4 million times the mass of the Sun. The stars nearest to it whirl in tight, graceful orbits, moving at incredible speeds. Their paths reveal the invisible grip of the black hole, a silent conductor orchestrating cosmic dance. Black holes are not all the same. Some are stellar mass, formed from single stars collapsing. Others are supermassive, found in the centers of galaxies, with masses millions or billions of times greater than the Sun. The largest black holes challenge our understanding of physics, holding more mass than entire star clusters. Between black holes, matter and light behave in strange ways. Time slows near the event horizon, a phenomenon predicted by Einstein's theory of general relativity. If you were to approach one, seconds for you would pass slowly compared to those far away. Gravity bends light, distorting the image of stars behind it. Space itself curves, reminding us that the universe is not flat, but a fabric that responds to mass and energy. Black holes can collide, merging into larger, more massive singularities. These cosmic collisions ripple through space-time as gravitational waves, subtle vibrations that were first detected only recently. They are quiet messages from distant cataclysms, traveling across billions of light years, reaching us as whispers in the fabric of the cosmos. Though they are often portrayed as destructive, black holes are essential to the universe. They regulate the growth of galaxies, influence star formation, and recycle matter back into space. They are not simply voids, they are dynamic participants in cosmic evolution, shaping the universe in ways we're only beginning to understand. The regions around black holes are often spectacular. Gas spirals inward, forming glowing accretion disks. Magnetic fields twist and launch jets of particles that stretch for thousands of light years. These phenomena create beauty amid danger, a luminous ballet performed on a scale almost impossible to imagine. Even in their invisibility, black holes leave marks that can be observed. Stars close by move in peculiar paths. Gas clouds are torn and heated. Light is bent and delayed. They are not empty, but full of power, quiet rulers of cosmic territories. Some black holes wander through space alone. Stellar mass black holes can drift between stars, hidden yet influential. They bend the light of objects behind them like invisible lenses, allowing astronomers to infer their presence. Even in solitude, they leave traces, connecting the seen and unseen. In the distant future, black holes will dominate. As stars die and galaxies drift apart, black holes may remain as some of the last luminous objects. Slowly, they evaporate through a subtle process called Hawking radiation, shedding energy over unimaginable spans of time. Their endings are as quiet as their existence, a fading whisper in the eternal night. When we think of black holes, we often imagine fear or destruction, yet there is calmness in their silence. They are ancient, patient, and consistent. They embody the universe's extremes, reminding us that existence can be both powerful and serene. Floating through space near a black hole, you would feel the immensity of gravity without sensation, observing the warping of light and time around you. The stars would bend, the galaxy would curve, and yet you would feel the stillness of the void. Black holes are reminders of scale, of forces beyond comprehension, and yet of balance within the cosmic order. Every black hole tells a story. Stellar mass black holes speak of lives that burned brightly and ended abruptly. Supermassive black holes tell of galaxies that grew and evolved, shaping entire regions of space. Their silent presence carries information, waiting for patient observers to decode. Even the most distant black holes send their messages across the universe. Gravitational waves, light distorted by lensing, and the behavior of surrounding stars are all forms of communication. Through careful observation, astronomers have begun to understand these silent giants, to see the patterns in their stillness, and to appreciate their beauty. So, as you lie quietly and let your thoughts drift, imagine the black holes in the universe, invisible, immense, and eternal. They are not threats, but guardians of cosmic rhythm. They teach us about gravity, about time, about the interplay of light and matter, and about the profound calm within the extremes of existence. They are part of the universe's meditation, deep and endless, a reminder that silence can be powerful and invisibility can be profound. In their quiet, they hold the weight of galaxies, the passage of time, and the whispers of creation itself. And tonight, as you breathe softly, let the idea of black holes inspire calm wonder. Consider the vastness of space, the gentle pull of gravity, and the quiet power that shapes stars, planets, and life. Drift with the universe, carried by forces both visible and hidden, and find peace in the stillness of these silent giants. In the quiet reaches of the galaxy, stars are rarely alone. Many are accompanied by worlds, orbiting in silence, bathed in the glow of their suns. These are exoplanets, planets beyond our solar system, waiting to be discovered. Each one is a story, a possibility, a whisper of what the universe can create. The first exoplanets were detected in the 1990s, revealing that the cosmos is filled with worlds, far more than anyone had imagined. Today, thousands have been catalogued, each with unique characteristics, sizes, and orbits. Some are rocky like Earth, others gas giants like Jupiter, and some are unlike anything we have seen before. These planets vary in their closeness to their stars. Some orbit tightly, completing a revolution in a few days, scorched by heat and radiation. Others are distant, wandering slowly in long elliptical paths, where temperatures plunge into eternal cold. Some worlds are tidally locked, showing one face to their star forever, like a quiet sentinel watching the glow while the other side remains shrouded in shadow. The search for exoplanets has revealed astonishing variety. There are hot Jupiters, massive gas giants orbiting perilously close to their stars. Their atmospheres boil, and their days are filled with unimaginable heat, yet they exist in stable orbits, a delicate balance between gravity and motion. There are planets with two suns, where sunsets are never simple, and the sky may be lit in ever-changing patterns. Some exoplanets float alone, ejected from their systems, drifting silently through space, invisible except for the faint warmth they radiate. Methods for discovering these worlds are as subtle as the planets themselves. Astronomers detect exoplanets by watching for tiny dips in starlight as a planet passes in front of its sun. Others measure the wobble of a star caused by the gravitational pull of orbiting planets. Each method is an exercise in patience, a quiet, listening to the dance of light and gravity across unimaginable distances. Some exoplanets orbit within the habitable zone of their stars, where temperatures could allow liquid water to exist. These are the worlds that spark dreams of life beyond Earth. Even a small rocky planet, bathed in gentle starlight, could host oceans, clouds, and climates shaped by currents, winds, and seasons. The imagination drifts easily here, pondering skies that look nothing like our own, yet follow the same laws of physics. Every exoplanet is a laboratory of extremes. Some have skies of red or purple clouds, rains of iron or glass, and winds that circle the globe in endless storms. Others are quiet, frozen spheres with surfaces untouched by time, where no light has ever changed the rocks beneath. They exist in the vast serenity of space, carrying the promise of discovery and the poetry of possibility. The discovery of exoplanets has reshaped our understanding of the universe. The solar system is not unique. Stars are rarely solitary, and planets are often plentiful. The processes that formed Earth are echoed in countless distant worlds, and the chemistry that gave rise to life may be present elsewhere, waiting for the right conditions to ignite. Some exoplanets orbit stars much older than our Sun, existing for billions of years, longer than Earth. Their histories stretch across time we can barely comprehend, their surfaces shaped by cosmic events before our solar system was born. Others orbit young stars, newborn suns just beginning to shine, their planets still forming from disks of dust and gas. The diversity of exoplanets is staggering. Some are small, dense and rocky. Others are enormous, with deep atmospheres of hydrogen and helium. Some are icy, their surfaces shimmering faintly under distant suns. Some orbit pulsars, stars that flash with radio waves and somehow endure in that extreme radiation. Imagine standing on the surface of a distant exoplanet. Perhaps the sky is a deep green or purple, lit by a star larger and brighter than the sun. Perhaps two suns hang above the horizon, casting moving shadows across jagged landscapes. The gravity may be stronger or weaker than what we know, the air thick with gases alien to our lungs, yet all of it obeys the same laws that govern Earth. Even the smallest exoplanets hold fascination. A planet only slightly larger than Earth could host mountains, oceans, and climates that change slowly, season by season. Each rock, each wave, each cloud carries a story shaped by billions of years of cosmic evolution. They are quiet worlds, yet full of potential, awaiting eyes to discover them and minds to imagine their possibilities. As astronomers continue to refine their methods, more worlds are revealed. Space telescopes like Kepler and TESS watch patiently, observing thousands of stars for the faintest hints of planetary motion. Each discovery is a gentle confirmation that the universe is abundant, generous, and endlessly creative. Even the distance between these planets and their suns is a matter of patience. Light traveling across hundreds of light years brings us images from the past, whispers of a moment long gone, yet captured forever. We observe these worlds as they were, not as they are now, and in doing so, we become connected to their history, their evolution, and their quiet existence. Exoplanets remind us that the universe is not empty, but filled with possibilities. They are worlds shaped by gravity, chemistry, and time, each orbiting its sun in silence, yet contributing to the richness of the cosmos. Some may never be seen directly. Others may one day be visited by distant observers, exploring landscapes as different from Earth as night is from day. In your mind, drift among these worlds. Imagine planets with skies of lavender, oceans of liquid methane, rings that shimmer faintly in the starlight. Imagine moons that cast shadows across surfaces, and suns rising and setting in slow, timeless rhythms. The universe is abundant with such quiet wonders, each one a cradle for imagination and discovery. Every exoplanet is a reminder that the cosmos is vast and varied. Earth is unique, yet it is part of a tapestry woven from countless stars and planets. Each one follows the same laws, yet manifests endless diversity, a gentle proof of the universe's creativity. As you relax tonight, picture these distant worlds orbiting their suns in silence. Their skies may never be seen by human eyes, yet they exist, quietly shaping and reflecting the nature of the universe. Drift with them, carried by light and gravity, imagining the endless possibilities that stretch beyond our own small sky. Exoplanets teach us patience. They remind us that discovery is slow, subtle, and careful. They carry the echoes of starlight, the remnants of formation, and the promise of future knowledge. And in that quiet, they invite calm reflection, a connection to the infinite and the gentle thrill of cosmic curiosity. Even in the vast stillness of space, galaxies are not stationary. They drift, they sway, and sometimes they collide in slow, majestic dances that span millions of years. These cosmic collisions are gentle in pace, yet immense in scale, shaping the structure of the universe and reminding us of the quiet dynamism that governs everything. Galaxies move under the influence of gravity, drawn toward one another by invisible threads of attraction. When two galaxies approach, their stars rarely crash directly, for the distances between stars are enormous. Instead, their gravitational fields interact, stretching, twisting, and warping the galactic shapes. Clouds of gas compress, triggering waves of star formation. New stars ignite like gentle fireworks, scattered across the merging spirals. One of the most famous examples is the future collision between our Milky Way and the Andromeda Galaxy. This event will not happen for another 4 billion years, yet it illustrates the universe's patience. As they approach, their mutual gravity will distort both galaxies, forming elongated arms of stars and gas. Stars may be flung outward into intergalactic space or drawn into new orbits around a combined center. During these mergers, black holes at the centers of galaxies may also coalesce, forming larger, more massive singularities. Their growth is slow, invisible, yet consequential. The gravitational waves released ripple across the universe, subtle reminders that motion at this scale can be both silent and immense. Not all collisions are between equals. Sometimes a massive galaxy absorbs a smaller one, drawing its stars and gas into tidal streams. These streams wrap around the larger galaxy like ribbons, stretching for tens of thousands of light years. Over time, the smaller galaxy is fully integrated, its identity lost, yet its material contributing to the growth of something greater. Cosmic collisions also enrich the universe with chemical diversity. Gas clouds compressed during these encounters form new stars, which in turn produce heavier elements through nuclear fusion. As stars die, they scatter these elements, seeding future generations of stars and planets. Every collision is a catalyst for creation, quietly driving the evolution of galaxies. Galaxies sometimes collide multiple times, creating complex structures. Elliptical galaxies often form from repeated mergers of spirals. Their stars settle into smooth, rounded distributions, orbiting the galactic center in intricate patterns. Though these galaxies appear calm from a distance, their past is filled with tumultuous interactions and the silent energy of reshaping. Even collisions at smaller scales, such as dwarf galaxies interacting with larger ones, have profound effects. The Milky Way itself is currently absorbing several small companions. Streams of stars and gas weave through our galaxy, remnants of past mergers that have occurred over billions of years. These interactions are part of a larger cosmic rhythm, gentle and ongoing, shaping the Milky Way into its current form. Some collisions produce spectacular visual effects. Gas clouds compressed by gravitational tides glow with newly formed stars. Dust lanes ripple and fold, creating shadows and filaments that trace the passage of immense forces. The colors of these regions tell the story of chemical reactions, radiation, and the birth of light. Images from telescopes reveal swirls of red, blue, and green, a silent symphony unfolding over eons. Collisions also affect planetary systems. Stars may be nudged into new orbits, sending planets on slow, sweeping paths across space. In rare cases, planets may be ejected into interstellar space, wandering alone among the stars. Even such upheaval is gradual, taking millions of years, and yet it demonstrates the subtle power of gravity acting across unimaginable distances. Galactic collisions are not destructive in the sense of immediate chaos. Instead, they are transformative. They rearrange matter, trigger creation, and set the stage for new cosmic structures. Each merger is a story of change, a quiet reminder that even in vast emptiness, motion and growth continue unabated. Consider the Antennae galaxies, a famous pair engaged in a slow collision. Long tidal tails stretch outward, filled with clusters of newly formed stars. Their dance will continue for hundreds of millions of years, reshaping both galaxies until they form a new, unified system. Observing them is like witnessing time itself unfold, a slow-motion ballet on a cosmic stage. These collisions also reveal the presence of dark matter. Though invisible, dark matter influences the motion of galaxies during mergers, affecting their speed and the shape of tidal tails. Through careful observation, astronomers can infer its distribution, adding another layer to our understanding of the unseen forces shaping the universe. Even when collisions are complete, their effects linger. The combined galaxies settle into new forms, enriched with elements and stars from each predecessor. Gas continues to collapse into new stars, and black holes continue to grow. The universe is constantly recycling, remaking itself in patterns both predictable and mysterious. Cosmic collisions remind us of scale. What seems violent from a human perspective unfolds over millions of years, silent and imperceptible to any one observer. The universe operates on rhythms far beyond our comprehension, where creation and transformation are quiet, patient, and inevitable. When you imagine drifting among colliding galaxies, picture the stars moving slowly around each other, the glowing clouds of gas compressing into new light, and the silent tug of gravity guiding every motion. Time stretches. The universe is vast, dynamic, and yet serenely ordered. Even in chaos, there is beauty. The light from these collisions reaches us across millions of years, painting a story in colors and forms, whispering of creation, destruction, and renewal. Each galaxy carries the memory of past encounters, and in observing them, we glimpse the history of the cosmos itself. As you lie quietly, imagine watching this slow-motion dance. Galaxies spiral toward each other, stars drift gracefully, and clouds of gas glow faintly in the distance. The collisions are immense, yet they are gentle on the scale of the universe. They remind us that change can be continuous, powerful, and deeply harmonious. Through these motions, the universe teaches patience. Creation is not instantaneous. Even the most dramatic events unfold over eons. Galaxies collide, black holes merge, stars are born, and light travels billions of years to reach our eyes. In their rhythm, there is calm, a slow meditation of matter and energy across space and time. And tonight, as you breathe softly, let your mind drift with the galaxies. Watch the slow dance of cosmic forces. Feel the gentle pull of gravity, the quiet fusion of stars, and the endless unfolding of space. In this vast ballet, the universe invites you to relax, to imagine, and to rest within its infinite silent motion. The universe speaks in many ways, not always with light or motion, but also with subtle energy that drifts invisibly through the void. This is cosmic radiation, a quiet whisper of the cosmos that carries secrets of its birth, its growth, and the forces that shape it. Long before planets, stars, or even galaxies existed, the universe was filled with a glowing sea of energy. When the cosmos was young, hot, and dense, photons, electrons, and other particles collided constantly. Time passed slowly in the sense of interactions, as matter and energy were tightly intertwined. As the universe expanded and cooled, the first light escaped, traveling freely for the first time. This primordial light is now detected as the cosmic microwave background, a faint hum of ancient photons bathing the universe. Cosmic radiation is everywhere. It passes through our bodies, the air around us, and even the walls of our homes. We cannot see it, but it is a constant presence, a reminder that space is never truly empty. Instruments sensitive to these faint signals can map the universe's earliest structure, revealing tiny fluctuations that later grew into galaxies, stars, and planets. High-energy cosmic rays also reach Earth from distant sources. They are charged particles, mostly protons, accelerated to incredible speeds by supernova explosions, active galactic nuclei, or other energetic events. When they strike Earth's atmosphere, they create showers of secondary particles, briefly illuminating the sky with invisible energy. Each cosmic ray is a messenger from the distant universe, a traveler that has crossed vast distances, carrying information from extreme environments. Cosmic radiation tells us about the life cycles of stars. When massive stars explode as supernovae, they release not only matter, but also energy in the form of radiation. This energy travels across space, influencing the formation of new stars and planets. It interacts with magnetic fields, guiding charged particles along invisible paths, shaping the distribution of matter in subtle ways. Gamma rays, the highest energy form of light, reveal the most violent processes. They originate from black hole jets, neutron stars, and colliding galaxies. Despite their intensity, gamma rays do not carry heat to us across space. They are silent witnesses of events that would dwarf any explosion on Earth. Observing them requires space-based telescopes, instruments that listen rather than see, capturing whispers from the energetic heart of the cosmos. Cosmic radiation is not merely destructive, it also fosters creation. When it interacts with clouds of gas, it can ionize atoms, triggering chemical reactions. These reactions can form complex molecules, some of which are the building blocks of life. In this sense, radiation acts as both sculptor and teacher, guiding matter toward new forms, even in the cold silence of space. Even our own sun bathes Earth in radiation, a gentle stream of particles and light that sustains life. Solar wind, composed of charged particles, shapes the magnetic field around our planet, creating auroras that shimmer in polar skies. These displays are a visible form of cosmic radiation. a quiet celebration of the interactions between energy and matter. Beyond the solar system, cosmic radiation is a record of the universe's history. It tells of stars that have lived and died, of galaxies colliding, and of black holes feeding silently at the centers of distant systems. Each photon, each particle, is a messenger carrying the story of events that unfolded millions or billions of years ago. Cosmic rays are also mysterious in origin. Some come from within our galaxy, accelerated by supernova remnants. Others arrive from intergalactic space, traveling across billions of light years. Their paths are twisted by magnetic fields, so that by the time they reach Earth, their direction no longer points to their birthplace. Yet by studying their energy and composition, scientists can piece together the puzzle of their journey, uncovering the subtle fingerprints of the universe's most extreme events. Radiation can shape the surfaces of planets and moons. Cosmic rays striking ice or rock create isotopes, slowly altering the chemical landscape. Over eons, these changes accumulate, providing a historical record of exposure to cosmic energy. Meteorites also carry traces of radiation, allowing scientists to reconstruct the environment of the early solar system and the forces that shaped it. Even the faintest background radiation has profound significance. It reveals the universe's uniformity and tiny irregularities. Regions slightly denser than others eventually became the galaxies and clusters we see today. The soft hum of radiation is a lullaby of creation, carrying the memory of the universe's first moments. Radiation also connects the smallest and largest scales. A single particle can carry information from a distant supernova or black hole, linking its tiny energy to structures millions of light years away. Every particle that reaches Earth is a reminder that the cosmos is interconnected, and that even the vast emptiness between stars is alive with motion and history. In this quiet, invisible world, we find patience. Cosmic radiation moves at its own pace, obeying the laws of physics without haste. It does not hurry to arrive, yet it always reaches its destination. In that, there is a lesson in calmness, in trust, and in the subtle power of invisible forces shaping everything around us. Imagine floating in space, surrounded by faint whispers of radiation. You cannot hear them with your ears, yet they are present, flowing through the void. Streams of particles and energy pass around you, painting invisible patterns that tell of creation, transformation, and eternal motion. The universe is speaking gently in waves and particles, inviting contemplation and calm reflection. Every breath you take is connected to this universe. The atoms in your body, shaped by stars and cosmic events, have been bathed in radiation for billions of years. You are a participant in this quiet dialogue, made of the same material and energy that flows through the cosmos. As you lie quietly, let your mind drift along these streams of radiation. Imagine them moving across galaxies, through nebulae, and past distant stars. Feel the calm of their consistency, the patience of their journey, and the depth of the stories they carry. Every particle, every photon, is part of an ancient meditation that stretches across space and time. Cosmic radiation is a lullaby of the universe. It carries the memory of beginnings, the energy of creation, and the silent rhythm of existence. By listening in imagination, by contemplating its presence, we can feel connected to the cosmos, immersed in its gentle, eternal flow. Tonight, as you breathe and relax, imagine this invisible whisper surrounding you. You are part of it. The universe is calm, vast, and endlessly patient. Cosmic radiation flows past you, a silent reminder of infinity, of history, and of the beauty that exists even in the unseen. Stars are the quiet architects of the universe. They are born, they live, and eventually they die. Each phase a meditation on time, energy, and transformation. Observing their life cycle reveals the delicate balance of forces that shape the cosmos and connects us to the same material from which stars are made. The life of a star begins in a nebula, a vast cloud of gas and dust drifting through space. Gravity pulls the densest regions inward, slowly forming a protostar. This process can take hundreds of thousands of years, yet in the universe it passes like a gentle sigh. Within this cloud, the material spins, heats, and compacts, preparing for the ignition of nuclear fusion. When the core reaches sufficient temperature and pressure, hydrogen atoms begin to fuse into helium. Energy is released, and a new star shines for the first time. This phase, called the main sequence, can last billions of years. The star achieves equilibrium, with gravity pulling inward balanced by the outward pressure of fusion. During this time, the star radiates warmth and light, shaping the environment around it. Stars vary greatly in size and lifespan. Small red dwarfs burn slowly, existing for trillions of years, their light steady and calm. Larger stars, blue giants, burn brightly but briefly, consuming fuel at extraordinary rates and living only a few million years. Their brilliance is a fleeting gift, yet they influence the universe profoundly, enriching space with heavier elements when they die. As stars exhaust their hydrogen fuel, they evolve. They expand into red giants or supergiants, their outer layers swelling while their cores contract. Fusion shifts to heavier elements, producing carbon, oxygen, and in massive stars, iron. This transformation is a slow, graceful unfolding, a gentle reshaping of matter and energy that will determine the star's ultimate fate. The death of a star can be dramatic or serene. Smaller stars like our Sun shed outer layers to form planetary nebulae, leaving behind a dense core called a white dwarf. This remnant cools slowly over billions of years, fading into silence, a quiet testament to the life it once lived. The colorful shells of gas cast off during this process drift outward, seeding space with elements that may become part of new stars and planets. Massive stars experience a more violent end. When their cores collapse, they trigger supernova explosions, releasing immense energy into the cosmos. These explosions are rare, yet their effects are profound. The shock waves compress nearby gas, triggering new star formation, while heavier elements forged in the star's heart scatter across space, enriching the universe with the material needed for planets, life, and future stars. Some of the densest remnants form neutron stars, compact objects with gravity so intense that a teaspoon of material would weigh billions of tons. Others collapse further, forming black holes, silent giants whose presence influences galaxies and light across vast distances. Even in their final states, these objects continue to shape the cosmos in subtle and profound ways. Binary star systems add complexity to this life cycle. Stars in close orbit can exchange mass, triggering bursts of fusion, novas, or even the merger of two white dwarfs into a single, more massive star. These interactions are gentle and slow on human timescales, yet their consequences resonate across light years, affecting surrounding matter and future generations of stars. Stars are responsible for the elements that make up planets and life itself. Hydrogen and helium formed shortly after the Big Bang, but all heavier elements originate in stars. Carbon, nitrogen, oxygen, iron, and countless others were created in stellar cores and distributed through supernovae or gentle stellar winds. Without stars, the universe would be a simple, empty place, devoid of complexity or life. The energy of stars also shapes galaxies. Stellar winds carve cavities in gas clouds, regulating the rate of star formation. Radiation pressure pushes dust and gas, guiding the evolution of surrounding regions. The light of stars illuminates the cosmic web, making visible the vast structures of the universe that would otherwise remain hidden in darkness. Stars also exhibit variability. Some pulsate gently, expanding and contracting in slow rhythms that can be measured as changes in brightness. Others erupt unpredictably, releasing sudden flares or shedding mass in bursts. These variations provide astronomers with clues about stellar composition, internal structure, and age. Each fluctuation is a heartbeat of the cosmos, a reminder that even stars, immense and distant, have cycles of rhythm and rest. In clusters, stars form together, bound by gravity and born from the same nebula. Observing these clusters reveals the interplay of age, mass, and evolution. Some stars shine in harmony, while others fade earlier, illustrating the diversity of stellar lifespans, even within the same birthplace. Clusters are laboratories of time, showing the universe in motion on scales we can measure and understand. Imagine floating among stars, drifting past their light and warmth. Each one is a story of birth, growth, and transformation. You can feel the gentle rhythm of fusion, the quiet pressure of gravity, and the slow unfolding of energy that powers the cosmos. In their calm brilliance, stars teach patience, endurance, and the beauty of change. Even the night sky above us reflects this life cycle. Every point of light is a witness to eons of cosmic evolution. Some stars you see may already be gone, their light traveling across space for centuries, reaching your eyes as a quiet echo of what once was. Others are young, just igniting, sending gentle warmth outward into the void. Stars connect all scales of the universe. From the atoms in your body to the galaxies billions of light years away, the material and energy of stars permeate existence. They are both anchors and messengers, creating, sustaining, and transforming everything around them. Each life cycle is a meditation, a demonstration of calm persistence in a universe vast beyond imagination. As you breathe and relax, imagine the universe's stars unfolding their lives. Picture the slow birth in nebulae, the steady glow of main sequence stars, the swelling of giants, and the peaceful or explosive ends. Let yourself drift with them, carried by light and gravity, feeling the gentle rhythms that have persisted for billions of years. The life cycle of stars is a lullaby of creation and transformation. It reminds us that even immense forces can act with calm patience, shaping beauty over time. In their quiet, the universe reveals its order, its subtlety, and its endless capacity for wonder. If we step back from individual galaxies and stars, the universe reveals another layer of structure, vast and elegant. This is the cosmic web, a delicate network of filaments and voids stretching across billions of light years, shaping the distribution of matter and the formation of galaxies. It is the universe's skeleton, invisible to the naked eye, yet governing the flow of cosmic energy with subtle precision. The cosmic web is composed mostly of dark matter, a mysterious substance that does not emit light but exerts gravity. Within this framework, gas and galaxies accumulate along filaments, creating long chains and clusters. Between the filaments lie enormous voids, vast regions with few stars or galaxies, silent and expansive, emphasizing the intricate pattern of the cosmos. Galaxies do not float randomly. They follow the contours of this web, traveling along filaments like beads on invisible threads. Clusters form at the intersections, where gravity concentrates matter into dense hubs. These clusters can contain thousands of galaxies, each orbiting the cluster's center, influenced by both visible and invisible forces. The cosmic web is revealed through observations of galaxies, quasars, and the cosmic microwave background. Light from distant sources travels along and through these structures, subtly distorted by gravity. Astronomers map these distortions to uncover the hidden scaffolding, unveiling the quiet architecture of the universe. Filaments of the cosmic web can stretch hundreds of millions of light years. Along them, galaxies are born, fed by gas flowing through the threads. These flows are slow, patient, and constant, delivering the raw material for star formation and growth. In this way, the cosmic web is not merely structure, it is a conduit for life in the universe, a gentle guide for creation across unimaginable distances. Voids between filaments are equally fascinating. They are enormous, sometimes tens of millions of light years across, containing few galaxies and even less gas. These empty regions emphasize the web's delicacy, the contrast between dense hubs and expansive emptiness. Despite their quiet, voids shape the dynamics of nearby galaxies, influencing motion and evolution in ways that are invisible yet significant. At the intersections of filaments, galaxy clusters emerge. These clusters are dynamic, with galaxies interacting, merging, and influencing each other's paths. Hot gas fills the spaces between galaxies, glowing in X-rays, while dark matter holds everything in a silent, gravitational embrace. These regions are the universe's grand meeting points, where motion, energy, and matter converge in subtle harmony. The cosmic web also carries clues about the universe's history. Its large-scale structure reflects conditions shortly after the Big Bang. Tiny fluctuations in density expanded over billions of years, forming the filaments and voids we observe today. Each strand of the web is a record of cosmic evolution, a testament to the patient shaping of matter and energy. Imagine drifting along a filament, surrounded by the soft glow of galaxies in the distance. Each one is part of a larger network, a gentle reminder that nothing exists in isolation. Gravity pulls, gas flows, and stars ignite, all orchestrated by invisible threads that span the universe. The scale is immense, yet the rhythm is calm, consistent, and beautiful. The cosmic web also highlights the role of dark energy, the mysterious force accelerating the universe's expansion. While filaments and clusters hold matter together locally, the overall expansion stretches the web, increasing the distances between structures. This duality creates a tension between cohesion and separation, a silent interplay shaping the universe's destiny over eons. Within this vast framework, galaxies evolve. Spiral galaxies trace the filaments gracefully, while elliptical galaxies dominate the dense hubs. Interactions are guided by both visible matter and the unseen scaffolding of dark matter. Star formation, black hole growth, and chemical enrichment all occur in the context of this underlying skeleton, revealing the cosmic web's subtle but profound influence. Even individual stars and planetary systems are affected. Gas flows along filaments may feed star-forming regions, influencing the timing and abundance of new stars. The chemical composition of interstellar clouds can reflect their position within the web, shaped by billions of years of cosmic currents. Every object, from the smallest star to the largest cluster, participates in the quiet orchestration of the web. Observing the cosmic web requires patience. Its structures are vast, its patterns subtle. Surveys of galaxies across billions of light years reveal the threads, while computer simulations recreate their growth and evolution over cosmic time. These simulations show how tiny initial fluctuations grew into the vast, elegant network we see today, a testament to the universe's balance between chaos and order. The colors and light of the cosmic web are muted. Individual galaxies glow softly, clusters shine in faint X-rays, and dark matter remains invisible. Yet the elegance of the structure is undeniable, a silent choreography of matter, energy, and gravity stretching across space and time. Imagine lying beneath the night sky and contemplating the cosmic web. The stars above are part of filaments, their position shaped by forces far beyond our perception. The darkness between them is not empty, but filled with invisible structure, guiding the universe's evolution quietly and gracefully. In this reflection, the universe appears both vast and intimately connected. The cosmic web reminds us of patience, subtlety, and persistence. It demonstrates that the universe operates on scales far beyond human comprehension, yet with calm regularity. Matter moves, galaxies form, stars ignite, and light travels along invisible threads, all part of a silent, ongoing meditation across billions of years. As you relax, imagine drifting along these cosmic threads. Feel the gentle pull of gravity, the soft glow of distant galaxies, and the quiet emptiness of vast voids. Let your mind float along this structure, sensing its patience, balance, and enduring beauty. The universe is vast, yet its rhythms are gentle, inviting calm reflection and awe. The cosmic web is the skeleton of the universe, subtle, patient, and eternal. It holds the cosmos together, channels creation, and preserves the history of everything that exists. In its quiet elegance, we can feel the deep calm of space, the flow of matter and energy, and the infinite possibilities of creation stretching across the stars. In the vast cosmos, most of the universe is unseen. Ordinary matter, the stars, planets, gas, and dust that we can observe, makes up only a small fraction of what exists. The rest is composed of dark matter and dark energy, invisible forces that shape the universe with subtlety, patience, and power. Dark matter cannot be seen directly. It does not emit, absorb, or reflect light, yet its presence is revealed through gravity. Galaxies rotate faster than expected, their stars moving as if pulled by unseen mass. Clusters of galaxies bend light from distant objects, creating gravitational lensing. These phenomena reveal the hidden scaffolding of the cosmos, where dark matter acts as a gentle architect, guiding the formation of galaxies and the flow of cosmic energy. Without dark matter, the universe as we know it could not exist. Galaxies would drift apart, unable to form stable structures. Stars would scatter, and the delicate balance of gravity that shapes clusters and filaments would collapse. This invisible substance, though intangible, provides the calm framework upon which the visible universe is built. Dark energy is even more mysterious. It is a force that pushes the universe to expand, accelerating the separation of galaxies. While gravity pulls matter together, dark energy pulls the cosmos apart, stretching space itself. It acts quietly but persistently, shaping the ultimate destiny of the universe. Over billions of years, it will carry galaxies ever farther from one another, creating a vast, serene expanse where the familiar patterns of light may slowly fade. The interplay between dark matter and dark energy is a delicate balance. Dark matter holds structures together locally, while dark energy drives them apart on the largest scales. Together, they orchestrate the universe's evolution, like two invisible currents shaping the tides of cosmic time. Their presence is felt, not seen, a silent influence that pervades every corner of space. Observing these forces requires ingenuity and patience. Astronomers study the motion of galaxies, the distribution of clusters, and the cosmic microwave background. Tiny fluctuations in light, subtle distortions of space, and the bending of photons all serve as clues. By piecing together these faint signals, scientists can map the unseen, revealing the vast ocean of dark matter and the quiet push of dark energy that defines the universe's structure and expansion. Dark matter forms vast halos around galaxies, a hidden cocoon that keeps stars from drifting away. These halos are gentle yet powerful, extending far beyond the visible edges of galaxies. They shape the orbits of stars, guide the formation of spiral arms, and influence the distribution of gas. Without them, the familiar forms of galaxies would be impossible, their beauty and order lost to chaos. Dark energy, in contrast, acts on cosmic scales, accelerating expansion between galaxy clusters. Its effect is slow, barely perceptible over human lifetimes, yet inexorable over billions of years. It transforms the universe into a grand, stretching canvas where galaxies drift apart like islands in an infinite sea. The quiet force of dark energy embodies patience, a subtle reminder of the universe's vast temporal rhythms. Together, dark matter and dark energy dominate the cosmos. Visible matter, the stars and planets we see, represents less than 5% of the total, yet this small fraction gives life, light, and wonder. Dark matter and dark energy provide the framework and energy within which these luminous objects exist, silently orchestrating cosmic order while remaining imperceptible to human senses. The influence of these invisible forces is evident even in the patterns of the cosmic web. Filaments of galaxies trace the contours of dark matter flowing along its threads. Voids expand under the influence of dark energy, creating vast, tranquil spaces that accentuate the elegance of cosmic structure. The universe's architecture is therefore a dialogue between the seen and unseen, a gentle conversation spanning billions of years. Some galaxies appear to rotate too quickly for the visible matter they contain. Without dark matter, they would tear themselves apart. Yet the unseen halos provide calm stability, a hidden strength that maintains order in the face of immense forces. These galaxies glide through space gracefully, a testament to the quiet work of invisible matter. Dark energy, meanwhile, continues its gentle expansion, stretching the universe like a slow breath. Galaxies move apart, yet locally they remain bound by gravity. Stars shine undisturbed. Clusters hold together, islands of structure in a gradually widening cosmic sea. This interplay between cohesion and expansion is subtle, yet it defines the universe's destiny and rhythm. The presence of dark matter and dark energy reminds us of the limits of human perception. We see the stars, the planets, the glowing nebulae, and the light from distant galaxies, yet the vast majority of the universe remains unseen. Understanding these invisible forces requires careful measurement, imagination, and humility, revealing that the universe is far more mysterious and serene than appearances alone suggest. Imagine floating in space, surrounded by galaxies drifting in slow motion. You feel the pull of dark matter, the silent guidance shaping their orbits, and the gentle push of dark energy, expanding the distances between clusters. Though you cannot see these forces, their presence is tangible, felt in the motion, rhythm, and calm persistence of cosmic evolution. Dark matter and dark energy also inspire wonder through their mystery. Scientists know little about their nature. Particles of dark matter may exist, or perhaps it is a manifestation of gravity itself. Dark energy could be a constant property of space, or something more dynamic, a force with subtle undulations across the universe. Their secrets remain hidden, yet their effects are unmistakable, shaping galaxies, clusters, and the fate of the cosmos. In contemplating these invisible forces, one senses the universe's patience. Dark matter holds, dark energy stretches, and the cosmos continues to evolve. Time flows slowly. Stars ignite and die, galaxies form and merge, all within the quiet guidance of unseen influence. There is a calm majesty in this invisible orchestration, a meditation on the persistence and subtlety of the cosmos. Tonight, as you breathe and let your mind drift, imagine the gentle presence of dark matter and dark energy. Picture galaxies held in invisible embrace, clusters slowly moving apart, and the universe stretching across unimaginable distances. Feel the calm rhythm, the quiet patience, and the hidden forces that have shaped everything you see and everything you cannot. Dark matter and dark energy remind us that the universe is more than what meets the eye. Most of its substance is hidden, yet it is real, guiding creation and evolution with serene consistency. In this quiet presence, there is reassurance, wonder, and infinite calm, a meditation in the vastness of space. The universe is not static. It is vast, dynamic, and continuously expanding, carrying galaxies, stars, and light across distances that challenge comprehension. This expansion is gentle yet relentless, a calm rhythm that has persisted for billions of years, shaping time, space, and the very nature of existence. The first clues about the universe's expansion came from careful observation of distant galaxies. Their light was redshifted, stretched toward longer wavelengths, suggesting that they were moving away from us. This discovery revealed that the cosmos itself was growing, that space was stretching, carrying galaxies gently apart like islands on an endless ocean. Edwin Hubble, through meticulous measurement, quantified this motion. He found that the farther a galaxy is, the faster it appears to recede. This relationship, now known as Hubble's law, is a testament to the universe's grand and orderly expansion. It's a slow, patient process, measured over millions and billions of years, yet it defines the rhythm of cosmic evolution. Expansion does not occur in a uniform sense locally. Galaxies bound by gravity, our Milky Way, for example, and its nearest neighbors, remain in relative proximity, orbiting and interacting over time. Yet on larger scales, across clusters and superclusters, the distances grow steadily, the universe stretching outward in a silent, majestic dance. This expansion affects not just the placement of galaxies, but also the flow of light. Photons traveling across billions of light years are stretched, their wavelengths elongated. Light from the earliest galaxies shifts toward the infrared, carrying whispers from the dawn of time. Observing this light is like listening to the universe's heartbeat, tracing history through the gentle stretching of space. Time itself is intertwined with expansion. The further we look, the farther back we see. Galaxies whose light reaches us from 10 billion years ago appear as they were in the distant past, revealing cosmic evolution in motion. Each observation is a meditation on time, a reminder that the universe is not merely vast in space, but deep in history. Cosmic expansion is also tied to dark energy, the subtle force accelerating the stretching of space. Over billions of years, this energy will carry galaxies ever farther apart. The universe may one day become a quieter, more isolated place, with stars and clusters separated by immense voids. Yet this slow unfolding is calm, deliberate, and awe-inspiring in its scale. Imagine drifting among galaxies as they recede. Their motion is not chaotic, but graceful, a gentle procession shaped by invisible forces. Distances grow, light stretches, and time flows. The universe expands without haste, an eternal meditation of space and energy, revealing that growth can be patient and harmonious, even on a cosmic scale. Expansion also influences the large-scale structure of the universe. Clusters of galaxies move relative to each other. Filaments stretch and voids widen. The cosmic web itself subtly elongates over time, preserving its intricate network even as space itself stretches. Observing these changes requires both precision and patience, as the motions are slow and subtle across human lifetimes, yet immense in scale. Even within this grand expansion, local processes continue. Stars are born, galaxies merge, black holes feed, and planets orbit their suns. Expansion does not halt these events. It provides the backdrop, the vast, calm stage upon which the intricate drama of matter unfolds. In this way, the universe balances growth with stability, change with continuity, motion with rest. Astronomers can measure expansion through multiple methods. Observing supernovae, mapping galaxy distributions, and studying the cosmic microwave background all provide evidence for the universe's growth. Each observation adds a brushstroke to a portrait of a cosmos that is both vast and intimate, expanding gently while preserving the order and beauty of its structures. Redshift is a subtle but profound consequence of expansion. Light from distant objects appears stretched, shifting towards the red end of the spectrum. This stretching allows scientists to estimate distances, map the universe's growth, and even infer the age of the cosmos. It is a quiet, patient signal, carrying the story of billions of years across unimaginable expanses. As we trace expansion backward in time, the universe becomes denser, hotter, and younger. All matter and energy converge in a single point, giving rise to the Big Bang, the ultimate origin of space and time. This event was not an explosion into space, but an expansion of space itself, gently carrying all that exists outward, shaping the cosmos we observe today. Over the course of billions of years, galaxies drift along with this expansion, yet local gravity allows them to cluster, form stars, and evolve. The universe's growth is not a destruction of order, but a framework for creation, providing space for galaxies, nebulae, and planets to develop, to shine, and to continue their intricate dance. Imagine lying quietly, floating alongside this cosmic motion. Feel the vast distances increasing, yet sense the calm that pervades. Galaxies drift, light stretches, and time flows, a meditation on the patience and rhythm inherent in the cosmos. Expansion is not abrupt or violent, it is a subtle, elegant unfolding, a reminder that even immense change can be gentle. Expansion also affects our perception of the universe. Some galaxies are now so distant that their light will never reach us, carried beyond our observable horizon. This boundary is not a wall, but a testament to the scale and quiet persistence of cosmic growth. Beyond it, the universe continues to evolve, serene and vast, in ways we may never directly observe. The expansion of the universe reminds us of perspective. Time and distance are relative. Light is a messenger of history, and every observation connects the present to the distant past. The cosmos is alive with motion, yet it is calm, organized, and enduring, a silent reflection of the patient forces that govern everything. As you relax, let your imagination drift with this expansion. Picture galaxies slowly moving apart, clusters stretching across voids, and light from the distant past arriving gently at your eyes. Feel the universe's calm patience, its subtle rhythm, and the harmony of motion and stillness across unimaginable scales. The expansion of the universe is a meditation in time and distance. It teaches us that growth can be gradual, change can be gentle, and even the vastest forces can unfold with elegance and serenity. In this reflection, the cosmos invites quiet awe, deep contemplation, and a sense of peace in the vastness of space. In the vastness of space, there are places of gentle creation, clouds of gas and dust that cradle the birth of stars. These are nebulae, ethereal formations that glow softly in the light of young stars, scattered across galaxies like cosmic gardens. They are stellar nurseries, where matter gathers, condenses, and begins the slow dance of transformation. Nebulae come in many forms. Some are emission nebulae, glowing brightly as high-energy photons from newborn stars excite the surrounding gas. Others are reflection nebulae, catching starlight and scattering it gently across space. Dark nebulae, dense and opaque, hide their secrets in shadow, forming intricate shapes that inspire imagination and curiosity. Within these clouds, gravity gathers matter into dense regions, compressing gas and dust until nuclear fusion ignites. Slowly, over hundreds of thousands of years, protostars emerge, radiating warmth and light for the first time. The process is patient and quiet, a meditation in slow creation, unseen except for the faint signals that reach distant observers. Famous nebulae, such as the Orion Nebula, showcase this stellar birth in vivid detail. Vast clouds of hydrogen glow red and pink, punctuated by clusters of young, luminous stars. Dark lanes of dust wind through the cloud, silhouetted against the light, creating a cosmic tapestry, both delicate and dynamic. Each region within the nebula tells a story of transformation, of matter gathering and igniting under the influence of gravity and light. Nebulae are not static. Stellar winds from young stars sculpt their surroundings, pushing gas and dust into pillars, cavities, and filaments. Ultraviolet radiation carves patterns of light and shadow, shaping the nebula with patient artistry. This process can trigger new waves of star formation, a continuous cycle of creation, subtle and enduring. Planetary nebulae are a different form, marking the final stages of stars like our Sun. When these stars exhaust their fuel, they shed their outer layers, creating glowing shells of gas that drift into space. The remnants are compact white dwarfs, slowly cooling and fading over billions of years. The expelled gas enriches the surrounding space with elements, ensuring that future generations of stars and planets carry the legacy of the past. Some nebulae are remnants of violent events. Supernova explosions scatter gas and dust outward, forming expansive clouds illuminated by shockwaves. These nebulae are both evidence of destruction and seeds of creation, carrying elements forged in the hearts of dying stars, ready to become part of new cosmic structures. Their glowing filaments trace the motion of energy and matter, a serene record of cosmic transformation. Nebulae exist in many scales, from small, dense clouds a few light years across to vast complexes stretching hundreds of light years. Each hosts its own microcosm of processes: star formation, radiation, magnetic fields, and chemical reactions. Despite their immense size, they convey a sense of calm, a gentle unfolding of cosmic time and energy that continues unnoticed by human eyes. The colors of nebulae are not random. They reflect the composition of gases and the energies of nearby stars. Hydrogen glows red, oxygen glimmers green or blue, and other elements contribute subtle hues, creating an almost painterly effect across the canvas of space. These colors are both aesthetic and scientific, providing clues about temperature, density, and chemical makeup. Nebulae also influence the formation of planetary systems. The gas and dust within these clouds can coalesce into protoplanetary disks around young stars. Within these disks, particles collide and stick, gradually building planets, moons, and other celestial bodies. In this way, nebulae are not only nurseries of stars, but also the birthplace of worlds, carrying the potential for life across the cosmos. The movement within nebulae is gentle yet persistent. Gas drifts along magnetic field lines, radiation pressure nudges dust particles, and turbulence stirs pockets of matter into denser clumps. Over millions of years, these small motions accumulate, giving rise to stars, clusters, and eventually planetary systems. The pace is slow, unhurried, and profoundly patient, a testament to the universe's rhythm. Nebulae are scattered throughout galaxies, yet each is unique. The Eagle Nebula, with its iconic pillars of creation, showcases towering columns of gas carved by radiation. The Helix Nebula, a planetary nebula, glows like a cosmic eye, its delicate structure illuminated by the central white dwarf. These formations invite contemplation, illustrating the universe's ability to combine power and tranquility, creation and calm in a single sight. Even within these clouds, life cycles continue. Stars die, gas is recycled, and new stars are born, each stage contributing to the slow evolution of the surrounding nebula. The interplay between light, matter, and gravity creates patterns of motion and stillness, a meditation on the flow of energy and time across vast spaces. Nebulae remind us of the intimacy within the vast universe. Although galaxies and clusters seem distant, nebulae operate on scales that, while immense, allow us to imagine the processes of creation in tangible ways. Observing them is a way to witness patient artistry at work, a slow choreography of forces shaping light, matter, and time. Imagine drifting through a nebula, Soft light filters through filaments of gas, stars ignite in gentle bursts, and dust swirls lazily across space. The movement is subtle, almost imperceptible, yet persistent. You feel the universe breathing, a calm rhythm of creation that spans millions of years and countless light years, inviting quiet reflection. Nebulae are both powerful and gentle, destructive and creative, vast yet intimate. They embody the patience of cosmic processes, the interplay of forces that shape everything from stars to planets. Their beauty is not fleeting. It is the result of slow, persistent evolution, a serene testament to the universe's enduring rhythm. As you lie quietly, let your mind drift among these stellar nurseries. Picture the soft glow of gas, the emergence of new stars, and the gentle shaping of matter by radiation and gravity. Feel the calm pulse of creation, the patient unfolding of energy and light, and the quiet artistry that continues, unnoticed yet profound, across the cosmos. Nebulae are a lullaby of the universe, a meditation on creation, transformation, and patience. They remind us that even in the vast emptiness of space, life, energy, and matter find ways to gather, ignite, and shape the future. In their gentle glow, there is serenity, awe, and infinite possibility. In the vast reaches of space, there exist objects so dense and mysterious that even light cannot escape their grasp. These are black holes, cosmic enigmas that embody both power and serenity, shaping the universe in ways subtle, profound, and enduring. They are the guardians of the void, silent yet commanding presences that influence galaxies, stars, and the flow of cosmic matter. Black holes form when massive stars exhaust their fuel. Their cores collapse under gravity, shrinking to a point of infinite density called a singularity. Surrounding this singularity is the event horizon, the boundary beyond which nothing can return. Though their interiors remain hidden from view, their effects on nearby matter are visible, creating patterns of motion, light, and energy that ripple across space. Despite their fearsome reputation, black holes are not cosmic vacuum cleaners. Stars and planets can orbit them safely at great distances, as long as they remain outside the event horizon. The immense gravity shapes orbits and flows of gas, guiding matter gently along paths determined by unseen forces. This interaction creates beauty in motion, a quiet choreography of energy and matter in space. Matter falling into a black hole forms an accretion disk, swirling in slow spirals, heating up as friction generates light and radiation. This glow is often brighter than entire galaxies, a beacon in the darkness of space. Jets of high-energy particles may emerge from the poles, stretching across thousands of light years. These jets are calm in their persistence, yet immense in scale. Reminders of the quiet power held by black holes. Supermassive black holes reside at the centers of galaxies, including our own Milky Way. Their mass ranges from millions to billions of times that of the Sun. Though their interiors remain shrouded in mystery, their gravitational influence governs the motion of stars, shapes galactic structures, and channels the flow of gas. They are anchors, invisible yet central, quietly orchestrating the dynamics of entire galaxies. Intermediate and stellar mass black holes populate the universe in smaller numbers, remnants of individual stars or merging systems. When two black holes collide, they send ripples through space-time known as gravitational waves. These waves travel silently, carrying information about the collision across billions of light years. Detecting them allows scientists to listen to the cosmos, capturing the gentle murmur of cosmic events that cannot be seen with ordinary light. Black holes influence star formation as well. Their gravity can compress gas in surrounding regions, triggering the birth of new stars. Conversely, the energy released from accretion can heat gas, suppressing star formation. In this way, black holes act as regulators, maintaining balance in galaxies, fostering creation while imposing order, a calm tension between energy and matter. Observing black holes requires patience and ingenuity. We cannot see them directly, but we detect their presence through gravitational effects, X-ray emissions, and the motion of surrounding stars. The first image of a black hole's shadow, captured by the Event Horizon Telescope, revealed a glowing ring surrounding darkness, a visual poem of gravity, light, and energy. This image, both scientific and profoundly beautiful, invites reflection on the quiet majesty of these cosmic guardians. Black holes also remind us of scale and perspective. They are immense in influence, yet minute in size compared to galaxies. A supermassive black hole may be only a few light years across, yet it holds sway over millions of stars. Their duality, small yet powerful, unseen yet essential, echoes the subtle interplay of forces that pervades the universe. Even the space surrounding a black hole is active. Time slows near the event horizon, a consequence of relativity. Light bends, paths warp, and matter traces graceful spirals. This is a meditation in physics, a quiet display of the universe's laws in extreme conditions. Observing or imagining this space evokes awe, a sense of serenity amid incomprehensible density. Black holes are also connected to the cycle of matter in the universe. Stars die, gas flows into these dense objects, and energy radiates outward. Over eons, matter is transformed, redistributed, and recycled. Black holes are not endpoints, but participants in cosmic evolution, silent yet profoundly influential. Some black holes exist in binary systems, paired with a companion star. Matter streams from the star into the black hole, creating luminous accretion disks and X-ray emissions. These systems are laboratories of motion, gravity, and energy, illustrating the patient artistry of forces shaping matter across space. Their light reaches us as a faint echo of processes unfolding over centuries, a gentle reminder of the universe's rhythm. Even in the vast emptiness around black holes, calm prevails. Space stretches, stars orbit, and radiation flows. The void is not chaotic, but organized, guided by gravity, energy, and the subtle influence of unseen forces. Black holes, while extreme, are embodiments of cosmic patience, balancing power and stillness in a silent dance. Imagine drifting near a black hole outside the event horizon, observing matter spiraling inward. Feel the immense gravity pulling gently yet relentlessly, the energy radiating softly from the accretion disk, and the calm order in the surrounding space. You witness creation and transformation, regulated by forces invisible yet precise. A cosmic ballet performed over eons. Black holes also teach us humility. Their mysteries are vast, their physics extreme, and yet their influence shapes the universe quietly, patiently, and beautifully. They remind us that unseen forces govern much of existence, and that silence and stillness can be powerful, shaping events across incomprehensible scales. Even as light and matter swirl around them, black holes remain serene. They do not hurry. Their processes unfold over millennia, millions, or even billions of years. They are reminders that in the cosmos, patience is universal, that transformation can be gradual, and that immense power can coexist with quietude. As you lie quietly, let your imagination drift near these guardians of the void. Picture the darkness, the glowing rings, the spiraling matter, and the distant jets stretching across space. Feel the calm tension between gravity and energy, creation and absorption, stillness and motion. Black holes embody the serene balance of forces that shapes the universe. In contemplating black holes, we sense the quiet majesty of the cosmos. They are extremes, yet they operate with order. They are invisible, yet their influence is undeniable. They are silent, yet they shape galaxies, matter, and the rhythm of space-time. In their presence there is awe, reflection, and deep calm. Black holes are the guardians of the void, the patient sculptors of the universe, and the quiet witnesses of cosmic time. They remind us that power and serenity can coexist, that the unseen can govern the visible, and that even in darkness, there is structure, purpose, and infinite beauty. As we contemplate the cosmos, our gaze extends not only to the past, but also to the unfolding future. The universe, vast and patient, carries within it the seeds of eternity, a slow, graceful evolution stretching across unimaginable time. From the birth of stars to the silent sway of galaxies, every process hints at what lies ahead, a meditation on existence and transformation. The expansion of the universe will continue, guided by dark energy. Galaxies not bound by gravity will drift ever farther apart, carried along by the gentle stretching of space. Over billions of years, the night sky as we know it may become sparse, with distant galaxies fading beyond our view. Yet, within this vast quiet, local clusters will persist, stars will shine, and pockets of creation will endure, testaments to the balance of forces shaping eternity. Stars themselves will continue their life cycles. Massive stars will burn bright and brief, exploding as supernovae that enrich space with elements. Smaller stars, like red dwarfs, will persist for trillions of years, their steady glow a lullaby across cosmic time. These stars will continue to ignite and fade, a rhythm of creation and transformation that resonates gently through the universe. Black holes will grow in influence. Through mergers and accretion, they will quietly accumulate mass, shaping galaxies and the flow of matter around them. Even as the cosmos expands and galaxies drift apart, black holes remain anchors, the silent custodians of energy and structure. Their presence reminds us that the universe is not random chaos, but a carefully balanced interplay of forces, patient and enduring. In the far future, stellar remnants will dominate. White dwarfs, neutron stars, and black holes will fill the cosmos, surrounded by sparse gas and dust. Planetary systems may fade as stars cool, yet the memory of creation persists in the material that remains, in the heavy elements that once shone brightly in living stars. Matter recycles, energy flows, and the universe continues its slow, elegant evolution. The cosmic microwave background, that ancient whisper of light from the universe's youth, will continue to cool and fade. Its presence is a reminder of the beginning, a faint hum of creation that has traveled across eons. Even as stars burn out and galaxies recede, this subtle radiation carries the story of the universe's origin, a meditation in light and time that persists across eternity. Dark matter and dark energy will continue their quiet influence. Dark matter holds together the remnants of galaxies and clusters, maintaining stability in a universe of growing emptiness. Dark energy stretches space relentlessly, shaping the large-scale structure and ensuring that the cosmos remains dynamic, patient, and vast. Their invisible presence is a constant, a foundation for the unfolding future. New stars may still form, drawn from remaining gas clouds. Nebulae, if any survive, will nurture the final generations of stars, continuing the gentle cycle of creation. Even in the quietest reaches, the universe will find ways to renew itself, a testament to patience, balance, and the persistence of energy across time. Imagine drifting through this future cosmos. The sky is quieter, the stars fewer, yet each light is precious, carrying the memory of countless generations. Galaxies float like distant lanterns in the stretching void, black holes anchor clusters, and radiation whispers the story of beginnings. You feel the calm, immense, and eternal nature of existence, a meditation in motion that spans billions of years. The ultimate fate of the universe may be one of gradual cooling, known as the heat death. Stars will burn out, Black holes will evaporate slowly via Hawking radiation, and matter will disperse across an ever-expanding void. Yet even this endpoint is gentle, not catastrophic, a quiet fading of energy rather than sudden destruction. The universe moves with patience, embracing stillness and calm in its final stages. Entropy, the measure of disorder, increases slowly, transforming energy from concentrated forms into diffuse warmth. Light and matter, once organized into stars and galaxies, will spread thinly across the cosmos. Yet within this process, there is a kind of serenity, a subtle rhythm in the transformation of energy, a slow unfolding of the universe's quiet destiny. Even in the far future, the universe remains interconnected. Particles trace paths that reflect their past. Black holes anchor remaining structures, and the faint glow of radiation carries the history of billions of years. The cosmos is a vast meditation, where time, matter, and energy flow with patient consistency, creating harmony even amid vast emptiness. As you reflect on this eternal future, imagine yourself floating gently through space. You drift past fading stars, through the quiet emptiness of voids, and along the subtle patterns of dark matter. You feel the calm patience of the universe, the gentle unfolding of energy, and the enduring rhythm of cosmic processes. This is a meditation in scale, a contemplation of eternity, and a lullaby of existence itself. Even as galaxies recede, the universe's story continues. Its expansion, the cycle of stars, the influence of black holes, and the whispers of ancient radiation all compose a symphony of calm, eternal motion. There is no rush, no chaos, only the patient unfolding of forces that have shaped and will continue to shape the cosmos. This vision invites reflection on our place within the universe. We are observers, participants, and part of the material legacy carried by stars and galaxies. Every atom within us has passed through cosmic processes, and every breath is connected to the universe's history. The vastness of space is matched by the intimacy of these connections, a gentle reminder of our place in eternity. As you drift toward sleep, let your mind follow the universe's calm rhythm. Picture stars igniting and fading, galaxies moving apart, black holes holding silent sway, and radiation carrying the memory of creation. Feel the patient flow of time, the quiet persistence of energy, and the infinite calm of a cosmos unfolding across eternity. The future of the universe is both vast and serene. It is a meditation on time, matter, and energy, an eternal dance of creation and transformation. In contemplating it, we find calm, awe, and connection, a reflection of the infinite beauty and patience that pervades existence itself. Tonight, as you breathe and relax, know that the universe continues its gentle motion. Its forces, visible and invisible, shape everything with care and patience. You are part of this grand story, carried by the rhythm of stars, galaxies, and the silent flow of space-time. The cosmos moves with grace, and within this eternal motion there is serenity, wonder, and profound calm.